Hello all my dear students, welcome back. Hope everyone is okay and enjoying his time. Today we have a very interesting lesson. It's Unit 2, Electric Energy. This unit consists of two lessons. Lesson 1, Electric Lamps, and Lesson 2 is Dangers of Electricity. Let's start our first lesson, Electric Lamps. But let's talk first about electricity or electric energy. Electric energy is one of the most important aspects in our daily life. Actually, we cannot imagine our lives without electricity. Before electricity, life was very cruel and boring. That's why people then started to search for other sources of light to overcome the cruelty of life, especially at night they had nothing to do. As in the morning they have sun, so they can perform any activity they want. Until a famous scientist called Thomas Edison invented the electric lamps. What are electric lamps? They are tools that convert or change electric energy into light energy. So these electric lamps just take electricity and give out light. They called it constant source of light. Why do they call it so? Constant source of light. First, constant means stable or unchangeable. So they called it constant because they didn't change the model that Thomas Edison invented it till now. We still use the same model with a little bit upgrading, but it's still the same one. Why? They didn't need to change it because actually it was perfect from its day one. Why it was perfect from its day one? Because it gives me clear and bright light, and in the same time it doesn't produce any smoke, vapor, or any odor. An odor means smell. So that's why they didn't need to change the model that Thomas Edison invented it. How many types of lamps do we have? There are several types of electric lamps used in our daily lives. But the most popular types of lamps are the light bulbs and the fluorescent lamps. Light bulbs, those rounded ones that produce yellow light, if you know. And the fluorescent lamps are the tall ones that we have in our classes, and they produce white light. Let's talk first about the light bulbs. Light bulbs are considered the most popular source of artificial light. The most popular means the most famous source of artificial light, and artificial means man-made. So the most popular type of lamps used everywhere is that light bulbs. Where do I see it? Where do I use it? It's used in every house. Also, it's used in car lights. Torches also are considered one type of light bulbs. What does it consist of? The light bulb consists of three main parts. Concentrate with me here, please. So, every light bulb consists of three main parts. Number one, the filament, which gives me the light, glass, bulb, and base. Let's talk about every part in details, but I'm going to start with the base. Let's take it from down to up. The base of the light bulb. It carries the lamp upright and connects the lamp with the electric circuit. That's where do I insert or fix my lamp into any electric source. I fix it with its base. So it carries the lamp and connects the lamp with the electric circuit or with electricity. Actually, we have two types of bases. The spiral base, which has one piece of lead at its end, or two-side nail base, which has two pieces of lead. So the base of each lamp, this is what carries the lamp. At the bottom of this base there is a piece of lead. One piece of lead if it's a spiral base, and two pieces of lead if it's two-side nail base. Out of this piece of lead there are two wires. These two wires are made of copper and lead mixture of copper and lead, so both wires are made of a mixture of copper and lead elements. These two wires are extending from down to up to end with my filament. This filament is made of a very special element which is called tungsten. Why do they make it from this tungsten? Because tungsten is a very special element. Actually, it's a metal and it has all of the properties of metals. They are shiny elements, good conductors of heat and electricity, malleable and ductile, all properties of metals, except only one property, which is so special and unique for only tungsten, which is what? That it glows and emits light when electricity passes through it, and this what gives me out the light that I see. Okay, so again, out of the piece of lead, two copper and lead wires are extending out and ends with my filament, which is made of tungsten. This unique element which is glow and emit light, which glows and emits light when electricity passes through it. Then here I have my glass bulb. This glass bulb, what prevents air from reaching to the filament. Why I have to prevent air from reaching to the filament? Because air contains oxygen, and if this oxygen, which helps in burning, reaches to my filament, it will burn it. So this glass bulb is very important because it prevents air from reaching to the filament. Here inside, around the filament, I have an argon gas, inert gas, or inactive gas. This argon doesn't burn and doesn't help in burning, so it keeps my filament safe. So I use it here to increase the lifetime of the filament. This makes my electric lamp live for a longer time. Okay, so again, the filament, it's a coil thin wire of tungsten in which electricity flows. It connected to two copper and lead wires. They are connected to the piece of lead at the base of the lamp. This is what we just said. The filament is made of tungsten. Give reason why. Because it has high melting point, it doesn't melt easily, and this is a common property among all metals, by the way. But the special property is that when the electric current passes through it, it glows and emits light. This is the point, and that's why they choose this tungsten and they didn't choose any other element. Number two, the glass bulb. It's to prevent air from reaching the filament and so protecting it from burning. Most of lamps contain one type of inert gases as argon or neon or xenon, but the most popular one is argon instead of air. Why? To increase the lifetime of the filament, to make the lamp live longer. And finally, the base. As we said before, it carries the lamp upright, connects the lamp with the electric circuit or with electricity, and there are two types of lamp bases: spiral with one piece of lead and two side nail base with two pieces of lead. The second type of the most popular electric lamps is the fluorescent lamp. The fluorescent lamps are known as neon lamps. Does this mean that fluorescent lamps are filled from inside with neon gas? Actually no, it's just a name. Fluorescent lamps are filled from inside with argon gas, just like the light bulbs. They are used in the houses, offices, schools, hospitals, and decorating commercial stores. If there is a store wants to put its name on its top, clear and bright so everyone can see it, they use this fluorescent lamps. And also the commercial advertisements, those huge boxes that we see everywhere, they are filled from inside with fluorescent lamps. Then they covered it with the advertisement that they want. If they want, for example, to advertise for a clinic, hospital, residential compound, a doctor, whatever. What does fluorescent lamps consist of? The fluorescent lamp consists of three main parts, just like the light bulb. What are these three main parts? First part is a glass tube. Number two, two filaments of tungsten. Number three, points of connection. Let's see at each part in details. Number one, the glass tube. This glass tube, what do we have inside it? We have three things. Number one, we have the inert argon gas. This what keeps the filament lives for a very long time. This what increase the lifetime of my filament, the argon gas. Number 2, mercury vapor. Mercury, did you hear about it before? Of course, yes, the only liquid metal that we have. It's a very good conductor of heat and electricity. But we are inserting it inside the fluorescent lamp in its gaseous state because it's mercury vapor, because it's easily to be inserted in its gaseous state than in its liquid state. That's why we insert it in the form of vapor. Number 3, the tube itself from inside is painted with a phosphoric material. And by the way, the mercury vapor and this phosphoric material, which are responsible for producing the white light that we see, due to a special reaction happens between them. Number 2, the 2 filaments of tungsten. Here I have 2 tungsten filaments, one at each side. They found at the tips of the lamps, but from inside. Number 3, the points of connection. There are 2 points of connection on each tip of the lamp to connect the electricity. So the points of connection which are found on each side of the lamp, those which are responsible for connecting the lamp with electricity. Then inside I have 2 tungsten filaments, one on each side also. Then the tube itself, it has a little amount of mercury vapor and inert argon gas and painted with a phosphoric material. That's all about the fluorescent lamp. Then if I want to connect too many lamps together, how can I do that? Of course, I can't choose only one lamp in each time. Sometimes I need in the same room more than one lamp. How can I connect electric lamps together? There are 2 methods to connect electric lamps, whether in the electric circuit or in the house. In the electric circuit, there are 2 other ways to connect lamps in the electric circuit, whether to be connected in series or in parallel. Let's talk about everything in details. First, connecting the electric lamps in the electric circuit. What's the electric circuit, or what do I need to make an electric circuit? All what I need is a battery, copper wires, and a light bulb or a lamp. And sometimes we add a switch or a button to turn my electric circuit on and off. By using these things, I will be able to make a simple model for an electric circuit, just a small thing. So what do I have here? I have a battery as a source of electricity. Then I have an electric lamp, and it's just an example for any electric appliance or equipment I want to operate by using electricity. I can exchange this lamp with my mobile if I want to charge it, with a refrigerator, with a TV, with anything works by electricity. Then finally I have the electric wires or the copper wires for connecting everything together. How does it work? First, when I press on my button and turn the circuit on, the electricity is going to pass out of the battery through wires until they reach to the light bulb, so my light bulb will light up. When I turn back again onto the switch and turn the circuit off, wires will be away from each other, electricity will not pass continuously, and my lamp will not light up. What does this mean? This means that my electric circuit cannot work unless it's closed. What's meant by closed? Closed means everything is connected together. There is a closed pathway for electric current to pass in. Batteries connected to the lamps by using wires. So it's a closed circuit. That's why we define the electric circuit as it's a closed path that let electric current passes through it. So it has to be closed in order to work. If I turn it on, all wires will be connected together, so the lamp will light up. If I turn it off, wires will be away from each other, so the electric current will not pass continuously and the lamp will not light up. How to connect too many lamps in the electric circuit? There are 2 ways, whether in series or in parallel. First, in case of the series connection, here as you can see, just a simple model for the electric circuit. I have a battery, I have wires, too many lamps, and a switch or a button. If I connect too many electric lamps together in an electric circuit in series, all lamps will be connected together beside each other or one after the other, as what can you see here in that figure. So this means what? This means that there is only one route or way for the electric current to pass through, only one wire for all lamps. All lamps are connected together in the same wire, and be careful from this point. If I want to increase the number of the connected lamps, what will happen? Remember that all lamps are sharing same wire, so the amount of electricity that passes through that wire will be split among the connected lamps. So the share of each lamp is going to decrease, which results in decreasing the light intensity of the light bulbs. But if one of them is burned, or if one of them is turned off, unscrewed, I removed it simply, what will happen to all other lamps? All of them will turn off. Why do all of them will why they are going to turn off? Because the burnt one or the removed one is going to act as a gap. So like this, the electric current will not pass continuously, as if I open the circuit, as if wires are away from each other. That's why all other lamps will turn off. So again, series connection. All lamps are connected beside each other. All lamps sharing same wire. Only one route for electric current to pass through. If I increase the number of connected lamps, intensity of light of each lamp is going to decrease. If any one of them is unscrewed, burnt, removed, all others will turn off. Now what about the other kind of connecting too many lamps in the electric circuit? It's called the parallel connection. In case of parallel connection, all light bulbs are connected in branching routes. So each lamp has its own wire. Each lamp has its own wire, and it's totally independent from other lamps. So there's too many ways or routes for the electric current to pass through, more than one. Now what's going to happen if I increase the number of the connected lamps? Nothing will happen. The intensity of light will remain the same. Why? Because each lamp has its own wire, and each wire receives the same amount of electricity regardless the number of branches. If one of them is turned off, unscrewed, burned, or whatever, all others will keep working because each lamp is independent from other ones. So again, parallel connection. In case I connect too many lamps in parallel in the electric circuit, each lamp is going to have its own wire or branch. So there will be more than one route for electric current to pass through. That's why if I connect or increase the number of connected lamps, intensity of light will not change and it will remain the same. If one of them is burnt, unscrewed, broken, whatever, all others will keep working. So which one do you prefer? Of course, the parallel connection. It gives me much more privileges. Now what about connecting electric lamps in the house? What do we have here in the house? All electric lamps are connected in the house in parallel. Each lamp has its own function, and the lighting in each room is independent from the lighting in any other room, so that turning off or damage of any of the lamps in a room doesn't affect the lamps in the rest of the rooms. That's very, very important. In our houses, each room is independent from the other. Even inside the same room, each button is independent from others. So if I want to turn on the light in one of the rooms, it doesn't mean that everything and all of the appliances is going to turn on the same time. No, I have to choose which one is going to be on and which others will be off, and which is a very, very important advantage about the parallel connection. Like this, we have finished our first lesson that talk about electric lamps and connecting electric lamps together. Thank you. Now let's talk about lesson 2, dangers of electricity and how to deal with it. But first, let's talk about electricity, which is very, very important for our daily life. I can say that almost everything around me work by electricity. The microwave, the television, the refrigerator, the deep freezer, the stove, the PlayStation, charging mobiles, computers, everything work by electricity. All these things which become essential in our daily life work by electricity. So I can say what that we cannot imagine our lives without electricity. But with all these benefits of electricity, and although that we cannot live without it, it can be very, very dangerous. It may cause fires, explosions, and sometimes it may lead to death. When could it be that dangerous? If we didn't deal with it in the proper way. So, and if I ignore or neglect the safety precautions that I should follow when I deal with electricity, at this time electricity could be very dangerous and it may cause too many dangers. We are going to talk about each one later in details. So, uses of electricity, it's used to cook food and preserve it, save it for a very long time, and it's also used to light our houses and operate machines and tools. That's about uses of electricity. But in the same time, as we said before, I have to deal with it cautiously. I have to deal with it carefully. I cannot ignore or neglect the safety precautions that I should follow when I deal with electricity. Only by this way electricity is going to be very safe and useful. But if I didn't so, it's going to turn me her dangerous face. Now, in order to deal with electricity in a proper way, in a safe way, I have to classify or divide the materials that around me everywhere according to their electric conductivity. Who's conducting electricity and who's not? Whose materials or which materials allowing electricity to pass through it and which others who do not allow electricity to pass through it. So here I have discovering the conductors of electricity and insulators of electricity. Materials are divided into two types according to its electric conductivity, the ability to pass electricity or not. Into number one, a group is called good conductors of electricity or electric conductors. Those are the materials that allow the flow of electricity through them. Like what? Like iron, in the form of a key or a nail or an iron bar. Also copper, which is the best electric conductor ever. Like what? Like to be in the form of a coin. The other group is called bad conductors of electricity or the electric insulators. Those are materials that do not allow the flow of electricity through them. Like what? Like the plastic, like rubber, wood and glass. Now let's talk about the dangers of electricity that we may face. Electricity is considered safe if it's handled cautiously or carefully, but if it's handled with neglection, hasteness, or in an improper way, it can cause a lot of dangers. What are these dangers? There are two types of injuries that may result from the improper use of electricity, whether direct or indirect. Direct according to what? Here, in case of direct injuries, electricity is a direct cause to have one of these dangers. Electric fire, a fire that happened because of electricity, directly. Electric shock, a shock that happens because of electricity also directly. And the burn that may result from an electric fire, or when I touch a machine that produces heat and it works by electricity. The burn that I'm going to have is called an electric burn then, because here electricity is a direct reason to have such a danger. The other type of injuries is called indirect injuries. Here electricity is an indirect cause to have such danger. Like what? Like those who's using the wooden ladders to walk with in order to hang like light branches from one side to the other. If he did any mistake, he's going to be electrically shocked. When he got shocked, he's going to fall down from the top of that ladder and he's going to have a broken leg. Now, what is the injury that he had? A broken leg. Why does it have it? Because he fall down. But why he fall down? Because of the electric shock. So here electricity is an indirect cause to have such danger. Now let's talk about the direct injuries or dangers of electricity that may happen, which are electric fires, shocks, and burns. Number one, electric fires. What are electric fires? They are the fires that occur due to the increase in the temperature of electric wires. How could it happen? For example, if I operate any electric machine by electricity, whenever I plug it into wall, electricity starts to pass through wires until they reach to my machine or appliance. The passage of electricity through wires produces heat, of course, based on the fact that says electricity produces heat. This heat is going to increase the temperature of my electric wire. If this temperature exceeds a certain limit, fires may happen. So what are reasons that may lead to an electric fire? I have here three reasons. Number one, putting items like furniture, curtains close to machines that generate heat. If I put any item like furniture, a chair for example, okay, or a curtain or a rug close to a machine that produces heat continuously, لا قدر الله, this may lead to an electric fire. Something else, operating more than one machine in one socket, okay, and this is the idea of the electric distributor. We call it in Arabic المشترك, which has too many sockets, so I connect too many machines in the same time to one socket, which is too dangerous. Okay, I shouldn't operate more than one machine to the same socket, especially the big machines like a refrigerator, a fryer, a microwave, the electric kettle in the kitchen. Such machines cannot be connected together in the same electric distributor, and doing so may lead لا قدر الله to an electric fire. The third reason is not disconnecting the machines that generate heat after use. Like for example, the most common example is the iron. Whenever I plug it into the socket and start to iron my clothes, when I just done, I forget to disconnecting it and keep it on for a very long time. So that's very dangerous, and it may lead to electric fire. Next, number two, electric shock. What's the electric shock? It's the result of an electric current passing through the human body. How does this happen? It happens when the human body is a part of the electric circuit, and when it closes the electric circuit and makes everything connected together, electricity will pass easily through the human body, in, through, then out of it. Why does it happen? It happens because the human body, more than 70% of it is water, and water is a very good conductor of electricity, and this is what makes electricity passes simply and easily through the human body. So electric shock happens when human body is a part of the electric circuit, so electricity is going to pass easily through it due to that 70% of the human body is water, and water is a good conductor of electricity. What are the three main reasons that may lead to an electric shock? Be careful. Number one of your body parts touches a wire, has an electric current in it, and touches the ground with another part. This happens, for example, if you touched your refrigerator while there is an electric problem in it, uncovered wire or something, but you can see it. So everyone touches this refrigerator will be shocked. So if you touch this refrigerator with one of your hands while you are stepped on floor with a bare footed, at this time you are going to be shocked. So again, one of your body parts like hands on the refrigerator while you stepped with a barefooted on ground. The other reason, one of your body parts also touches a wire, has an electric current in it, and touches a material conducting electricity with another part. Same case, same example, one of your hands is on that broken refrigerator while you are stepping on a good conductor of electricity material. Finally, touching wires conducting electricity. Touching any uncovered wire while electricity is passing through it. Those are the three main reasons that may lead to an electric shock. What are the harms that may happen due to the electric shock? Electric shock could be sometimes fatal. It may lead to death. And some other times it could be light or simple, so the person can survive after it. This harm or the severity of the electric shock depend on what? It depends on, number one, the strength of the electric current passed through the human body. Is it very strong current, a lot of electricity, or it just a small amount of electricity that passes through the human body? Number two, the time taken for electric current to pass through the human body. The time of exposure. How long does it take the human body to be exposed to electricity? That's a very important point. It's just a small touch and he can go away, or he kept connecting to the electric circuit for a very long time. So here I have two main factors on which the severity of the electric shock will be: the strength of the electric current and the time taken for the electric current to pass through the human body. Finally, number three, the electric burns. Electric burns, those are burns that causes damage of the body tissues. Whenever you get burned, the body tissues that exposed to the flame or to the hot surface, these tissues will be damaged, and that's why its color changes and takes a very long time until they return back again to its normal color due to the damage of the human body tissues. What are the reasons that may lead to an electric burn? For example, if you exposed to an electric shock, because electricity produces heat. So if you kept connecting in an electric circuit and if you kept shocked with electricity, this electricity produces heat and it may lead to an electric burn too. Second reason, it may happen as a result, of course, of an electric fire. If you exposed to an electric fire, a fire that happens because of electricity, the burn that you will get is called an electric burn. And finally, touching machines that generate heat. Touching any machine that generate heat, like the iron, like the stove, like the electric kettle, or whatever. So whenever you touch a machine that produces heat and it works by electricity, the burn that you will get is also called an electric burn. And now, how can I avoid all of the previous dangers? What are the safety precautions in dealing with electricity? What are these instructions that I should follow in order to deal with electricity safely and cautiously? Here we have some points. We are going to talk about them. Number one, do not connect several connections in the same socket. This point that we talked about it before in the electric fires. I shouldn't connect too many machines in the same electric distributor, especially the big or heavy machines, in order to avoid any electric fire may happen. Second point, do not insert a metal object in the socket. Why especially metal? Because metals are good conductors of electricity. So if I insert any metal object into a socket, this may lead to an electric shock. Number three, don't play with electric connections, especially kids. I have to prevent them from playing with any electric connections, and actually I have to hide them. 4. Do not leave wires naked or not insulated. If there is a rubbed wire, I have to cover it. I can't leave any electric wire naked or uncovered or not insulated, because if anyone is going to touch it by accident, he's going to be shocked. 5. Place a piece of plastic in the socket to prevent inserting another body in it. Any house which has any kids inside, they have to do so. Cover all of the sockets that they have with a plastic cover in order to prevent any of them to insert a metal object in any socket, so he's going to be shocked immediately. Then, do not leave an electric machine or heater connected with electric current while taking a bath. Yani just an example, just to pay attention to any electric machine which is already connected to electricity. I can't leave it on for a very long time without use. Whenever I'm done with it, I have to disconnecting it immediately in order to avoid electric fires, لا قدر الله. Do not touch electric machines that are connected to the electric current with a wet hand. Here I have 2 points. Number 1, do not touch electric machines that are connected to the electric current, because electricity produces heat and I may get burned. But with a wet hand, wet means has water, and water is a very good conductor with electricity. So if I touch any one of them while it's working with a wet hand, I might be shocked. And finally, do not try to fix, maintain or clean any electric machine while connected with electricity or with electric current. And that's the advice that I give to all moms. If you want to clean up the microwave or the refrigerator, electric kettle, oven, whatever, you have to disconnecting it first. I can't whether fix, maintain or clean any machine unless it's disconnected from electricity. Those are the safety precautions that we should follow while dealing with electricity to stay safe from all of the previous dangers. Thank you so much and wish you